So let me continue the next steps. So now choose, see whether you can get 1, 1, 1. So I mean, you don't need to go my order, okay, when you are doing the exams. So first of all, you can choose 1, 1, 1, okay. That is also okay. But I'm taking because to make the process easier, okay. So now the equation number 2 will be changed. What is equal to dx plus dy, because I am multiplying by 1, 1, 1. So dz divided by y plus z, x plus z, x plus y. So what do you think? So no minus, no? All are plus. So this should be equal to d of x. I'm writing commonly this one. Okay. Since of the differential equation is a linear operator, I can write this way. Okay. Linear operator. It means it's like it's equal to dx dy. It's like a cancellation of I mean it will be okay. Okay. In some operations. So y, there are 2y, 2x, 2z. So I can take 2 out. Again, x plus y plus z. Okay. So this is one of my, let's say, yeah, fifth equation. Okay. So still we are equating to the 2 now. So my 3 or 4, I can make equal to the 5 also. Okay. So let's choose any of that. Okay. 3 or 4, anything you can choose. Okay, shall I erase this window? Can you write down your things? Okay, I'll erase, okay? So, what do you think? So, let's equate our 3 and 5, okay? So, let me write this way. D of x minus y minus x minus y, which is equal to d of x plus y plus z divided by 2 times x plus y plus z, okay? So, now can you rearrange? Yeah. So if I integrating both sides, okay. So what is the integration for this one? So x minus y, this is dxy. So we know ln x minus y. I have minus also, okay. Equal to c x plus y plus z, x plus y plus z. So I have one constant, so I can take out the constant. Still it works ln x plus y plus z, okay. So I can choose my constant c2. Let me choose half, okay. So I can take out the half. So if you do that one, can you do the simplifications? So it's like, okay, I'll choose minus, okay. So I can take this one this side, this one this side. Okay, this is a constant, no arbitrary constant. We can choose any one, anyway. Okay, I'm taking minus c, l and c2. So I'm taking this side and this one this side. So it will be like I'm going to multiply the half also by all the term by 2. So x plus y plus z. So this will go this side now. So plus, so there's no half here. So 2 times ln x minus y is equal to, so if you are multiplying by 2, this will be go. So ln c2. Okay. So since these two are plus for ln, so it will be ln x plus y plus z times. So I can take as a power now. These are ln rules, okay? N ln x will be xn, ln xn, okay? Similarly, if you have ln x plus ln y, you can ln xy, okay? Similarly, if it is minus, you can take as a, these are ln rules, you may know, these are school things, okay? So I can multiply this one, take the power. So x minus y whole thing square, okay? This is equal to ln c2. So these steps I don't need to explain you. You know everything. Okay. So if I take off the ln, my final answer x plus y plus y times x minus y whole thing squared is equal to C2, where C2 is an C1 and C2 are arbitrary constant. Okay. You should write because the question doesn't have C1, C2. So if you are taking, you have to tell what you are taking. Okay. Constant. Now we have found our chi, no? Chi. Chi also XYZ in the form of XYZ. Okay. So what is our general equation? After that, you can write. Our general equation will be, therefore, our general equation will be G of this one. So G of, what is our early equation? Yeah. C1 will be x minus y divided by y minus z, no? This will be this. Okay. Write down. X plus y plus z times x minus y whole thing squared. So it's equal to 0. Yeah, G is a arbitrary function. Okay. This is our final answer. So these questions have some repeated multiplier finding. Okay, finding the multiplier repeatedly to get our. We can't do like our type 3. We have to go for repeated multipliers to get our to C1 and C2. Okay, so this kind of question we are allocated up as a type number 4. All right. Okay. Hope you have understood. So if you have any doubt also, you can ask me. You can check. Okay. Hope these are okay for you. Okay, I can give you some example for this question also. You can try. This is also one of the example. Yeah, shall I erase? Did you get all the answers? So if you are finding any problem or anything, you can ask me, you can chat with me so I can know. Okay. So if you don't understand also, you can ask me. So these are just regular integral things. Okay. Okay, I'll give you some examples, exercise for you for under these questions. Try this one. Try all the possibilities of multiplies, okay? To see whether you can done. So everything x, y, z, you can choose 1, 1, 1, x, y, z, 1 by x, 1 by y. Those kind of, you can try all the way because these are exercises, so you can try yourself, okay? So if you need, I will give you the answer. So it will be easy for you to check your answers, okay? Our G will be xy and x plus y times x plus y plus z. Okay, check whether you get this answer. Okay, answer. This is our first question. So let's do another question also. X cube plus 3xy squared of p. This is squared, okay. Plus y cube plus 3x squared y of q, which is equal to 2z of x squared plus y squared. So I can give this answer as well if you see. It's like a minus 1 over x plus y, 1 over, okay. Xy over that is. Try this question also, okay. So this is the answers. So you can check from your answers and whether you are getting the correct answers or not, okay. So we have finished the linear part, okay? So that means Lagrange's. I'll show you our, yeah, this one. So we have studied, check whether we have studied our, this one, outcome, these two forms. So we have finished our chapter 1, okay? Chapter 1, you can be ready for the exams when you are coming, okay? Similarly, we have done our intended learning of fourth one, okay? First order PDE by Lagrange's method. We have finished, okay? So we are in the chapter number 2 anyway. We have finished this linear equation, characteristic Lagrange equation. Next one, we're going to go for nonlinear equation kind of a solution method, which is called as a Chapitz method. So solve for first order nonlinear PDE by Chapitz method. Okay. So we can start from there. This is still we are in chapter 2. Okay, this continuation will I will put as a chapter 3. Okay, so that will be next thing. So we have 1 hour. Yeah, so we can see the Chapitz method as possible. Okay. Okay. So okay, put the heading nonlinear first order partial differential equation. That's a section number 2. You can put as a section 2. I didn't get the time to type the thing, so chapter 2. Okay. So chapter 2, section 2, which is non-linear, this one, non-linear first order PT, okay, partial differential equation. Okay, we are still in the first order, okay, as you know, we have only ZP, comma Q only available, okay, this will be ZX, this will be ZY, okay. So if it is so, but earlier, is the Lagrangian one, we have seen for the, linear, quasi-linear, okay, kind of a linear, okay. But what is the definition for the non-linear? Non-linear means? So which are the equation you are considering as a non-linear? Can you answer me? If it is non-linear, what you may find in the equations of PD? How you can distinguish between the linear and non-linear equations? Okay, I got one answer. No, yes, anyway, that is correct, but I'm asking the specific. So which make you to think that the equation is non-linear? If it is not linear, we know that is non-linear. But which kind of equation, which kind of characteristics, which shows it is non-linear? Okay, why I'm getting only one answer? Where's the others? There are 40 people are there here. Where's the others answers? Yes, that is one of the answer. Okay, correct. So what else? What else make you to think one of the ODE or PDE equation is non-linear? So think about in the way of ODE also or PDE in that sense. Let me call the people. Let's see. Why everyone is silent? 009. Can you answer me? What is the definition for us nonlinear PDE? What makes it nonlinear? Yes, the answers. Not anyone here? Why nobody answering? Where 009? Okay. Yes. Okay. That is one. What about there's two? I can say two, possibly. Yes, yes. Okay. 003 is correct. 009. Okay. Okay, got the idea, but in the same way. Okay. What is the possible answer from one of the students? It says all degrees are one and not multiplication of dependent variable and that derivative. Yes, that is the definition for the linear, no? Linear means what? It should be like all the powers should be one and no need to be z times of p. So if it is so also, we find as a non-linear, no? So in that case, so that is the definition for the non-linear. Okay, we should have all the powers are should not be more than one. Okay, and not the product of dependent variable with the derivatives. Okay, so this kind of definition, that's what I expected from you. Okay, all right. So in that case, non-linear first order PDE, we're gonna see the solving method of so linear, semi-linear, anyway, quasi-linear one, we have seen Lagrangian method, that is auxiliary equation and things we have found. There are 4 types. Okay, that's all we have finished. Now we are in the non-linear case. Still we are in the first order. Okay, first order means what? So we have P, Q, R, S, T, no? So P, Q, R, S also. Sorry, R until R we are in. So these two are second order, no? R, S, T are second order. So these two are only the first order. Okay, these are PXY, sorry, ZXY and Z X square, ZY square, something like that. Okay, so we still in the first order. So we are just having in our equation, you can see this is a nonlinear PDE which has XYZ as well as P and Q only, no RST. Okay, so this write down this question. Consider the nonlinear PDE if XYZ P comma P is equal to 0. No, don't put the heading, this heading. Yes, yet. Okay. Okay, no problem. So if you have a power cut or anything, please join quick as possible when you get it. Okay. Try to be in the lecture. Okay. Let's first of all, let's derive the things. Okay. Likewise, in our auxiliary equation also, we have derived the, we have proved how it has been, no? So let's do that here also. So now put the heading. So we know the nonlinear PDE in the form of this one. Okay. Now put the heading Chapit's method for solving nonlinear PDE. Okay, this should become here. Chapit's method. Okay, one of the person's name, Chapit. So Chapit's method for solving nonlinear PDE. So let's first of all let's derive it. Okay, then we can use it in our solutions. Okay. Yeah. Rather than showing it, I will do that. Okay. So I'll take my window. So please write with me uh, or take the screenshot as possible. So I need to have a spaces. So I will delete. Okay. So, okay. Now consider, let's derive the equation of Chapek's, okay? Consider the nonlinear PDE f of x, y, z, p, comma, q, which is equal to 0 as equation number 1. Okay. Now differentiate with respect to x. Okay. So differentiate the equation number 1 with respect to x. Okay. So if you do that, you'll get da bar f over da bar x, because f is the function of x, y, z, p, comma, q. So it will be a partial differential equation, which is equal to what you'll get da bar f over da bar x times da bar x over da bar x. Similarly, da bar f over da bar y, which will be da bar y over da bar x, plus da bar f over da bar z will be da bar z over da bar x. We also have p also. Okay, again we are taking da bar f over da bar p also, because it is also a variable now. Again da bar p over da bar x, plus still we, because this ps zx we know, anyway we are taking the derivative. Okay, da bar f over, because of the non-linearity, q da bar q over da bar x is equal to 0. Okay, this side. Now see, can you simplify this one? What is that? Da by f over da by x will be, this will be 1, no? Da by x over da by x will be 1. So this will be da by f over da by x plus, what do you think, da by y over da by x? Can you get the answers? Da by f over, sorry, da by y over da by x will be? Okay. Let's see others. Yes, good. So it will be 0, no? Because y is not dependent on x. Okay. But we have, I told you that that will be a function of x comma y. So I can take this one, no? So I can take da bar f over da bar z times. So I can write this one as a zx for now. Okay. Plus, this also happen, no? This also okay, because da bar p is depend on z, no? So this will be, let's take as px, small px. Okay. Similarly, da bar f over da bar yeah, q, which is equal, this is p, no? P, this is q, and I'm going to take qx, which is equal to 0. Okay. So now continue. For continuous functions, okay, uh, z, I'm taking as a continuous function, because it has continuous derivative. Okay. So we know we are taking small p as zx, no? So what do you think of py? Py will be, can you give the answer? Similarly, q is equal to zy. What is qx? Can you give the answer of small py? Okay, this is a small. No, don't write the capital. Okay, small py. If it is p is equal to z, what is py? If q is equal to zy, what is qx? Can you answer me? That's the answers. No. Think again. Yes. 118 is correct. Think again. Yes, is the answer. So we know that one, no? Let's say P is equal to ZX. What is P? Y. So ZX of Y, no? What is that? No, yeah. How comes it is equal? So what is ZX of Y? Again, ZXY, no? Similarly, if you think Q is equal to ZY, what is QX? So ZY of X, which is equal to ZYX. Is that correct? Yes. So we got here ZXY. Similarly, this is YX. So since of continuous functions, okay, we should have therefore Px equal to Qy. Sorry, Py is equal to Qx. Other way, okay. Since of continuous functions, this one. Okay, we're gonna use that one anyhow, okay. All right, so shall I erase one? Take a screenshot or write down the things. Okay, I'll erase, okay. Okay, now let's continue. So our DABA f over DABA x can be simplified as fx. So still I'm writing DABA f over DABA x as fx, okay. I'm changing the notations. This one, next one I can write fz of p plus fp of px plus fq of qx, which is equal to 0. Okay, let's take as a 2. Now we continue, we treat this as, okay, what kind of equation is this? Kind of like something p, something like that, okay? So it has been turned into, okay, this as quasi-linear equation. Quasi-linear equation. We have treating this as a quasi-linear form, okay? Quasi-linear equation. Therefore, let's take, what is the quasi-linear form? Can you tell me? What is the form of the quasi-linear? I mean, yeah. Can you tell me? So from that too, we use the auxiliary equations. So what is that quasi-linear equations? I mean, general way of representing the quasi-linear. Yes, good. One only answer. Where's the other? So what is the general quasi-linear equation representation? So again, our meeting will finish in 10 minutes. So, okay, join soon. Yeah, good. I got 2 answers. Where's the others? Okay, I'll go fast, okay? So this means we have to have PP plus QQ is equal to R format, okay? So I'm going to change this equation number 2 to on that form. It means what? I'm going to keep the P and Q form this side, okay? So this is my P form now. So I'm going to keep Fz of P plus, what is Q? Where's the Q? Sorry. For that, I'm taking this one, okay? Since of this Px, I'm treating Px as a these two as even though it is a nonlinear equation, I'm taking treating as a quasi-linear form. Therefore, I'm taking this plus other one. Let's say What is this one? Yeah, this will be P, no? Sorry, this will be P, this will be Q time QH, okay? Which is equal to, I'm taking all these two terms this side, okay? Because of 0, if I take this side, it will be negative of Fx plus Fz of P, okay? So I'm treating this as, anyway, this is not a quasi-linear, but I'm treating this as a quasi-linear form of using the P and Q, okay? Now, if it is so quasi-linear equation, okay, write the auxiliary equation for this one. Auxiliary equation of is for this equation. So what is our, if it is PPQQ is equal to R, what is the auxiliary equation? So it will be dx over P, dy over Q, dz over R, no? So in that sense, if you write the, auxiliary equation, you will have, let's write dx over, so I'm treating this one as a P and Q, no? So this only I need to write, okay? Capital FP, which is equal to dy again, this term, okay? FQ, which is equal to dz divided by whatever this one, no? So minus fz plus, fx, fz, p, okay? So I'm going to take this as one of the constant k. Let's take as a constant k, okay? So take this one as the equation number 3. Okay. Shall I write? Okay. So let me continue. Again, differentiating equation 1 with respect to y. So I'm not gonna do it. Okay, I'll give you the you do these steps. Okay, I will give the final answer. Okay, so we will end up as da by f over da by y, which is equal to f a similar way. Okay, no, nothing different. So q plus fp py plus fq qy, which is equal to 0. So if I write, if you then write, we treat this is also as a quasi-linear equation. Okay, we treat this as quasi-linear equation. So write down the quasi-linear equation form. Then the auxiliary equation. Okay, same things. Okay, I don't need to continue. You just fill up all these steps. Okay, don't keep blank. Okay, then I can write dx over again fp. Since this is fp, this is equal to dy over fq, is equal to this no. So dz over whatever comes minus fy plus fz of q. Okay. So this okay, I made a mistake. Yeah, in early equation. Okay, equation number is a 3. In the 3, this should be x dx over fp, that is correct. Dy over fq, that is correct. Okay, this is equal to dp. Okay, write down dp minus something, that is okay. Just put this one, not the z, no. We are treating as p. Okay, because we are taking p as a this as a this one we are taking as earlier one. We have fx plus fz of p, no. So according to that, we are taking dp. Okay, not z. So similar here also, dq also, dq fy plus fz of q. Please change around. So this is, I can also write as a k. Just write k. Okay. So we have found two equations. This is number 3. This is number 4. Let's take this as 4. Okay. So these two are same. Okay. Sorry. So these two are same. These two are same. Something. So we need to derive some connections. Okay. All right. So I will continue. So please write down the things quickly. Fill up these steps also. Okay. Don't keep blank. Write everything. Okay. Yeah, I'll erase. Okay. So yeah. Now let me continue. Now z is equal to take z of x comma y. Okay. So as you know, we already have the function z is equal to z. So what is dz? Can you find the dz? Total derivative will be da bar z over da bar x of dx plus da bar z over da bar y of dy, isn't it? So if I change into this one is p small p of dx, small q of dy, okay? Then um so from the equation number 3, equation number 3, we have dx over fp which is equal to dy over fq. So correct number minus dq over fy plus fzq which is equal to k. No? So from that, okay. Okay, from that, forget about this one. Okay. Take only this term and this term. Okay. Dx equal to what? Dx equal to fpk, no? Similarly, dy is equal to fqk. Okay. So we can substitute this one. What is dx? What is dy? Okay. I think our meeting gonna end now. So join again. I will explain this. Okay.